Welcome back, everyone, to another episode of Hypertrophy Past and Present. Thank you for joining us. Chris, how are you going this week? I made the joke that you're a professional podcaster, and in fact, you certainly are now, because this is your basically it's your third podcast in like 24 hours, 48 hours?
Less than 24.
Less than 24 hours. Okay, there you go. You haven't left your desk. You've just been sitting there podcasting constantly for almost a day.
I stopped to sleep and then I'm back on it again. Yeah. So yesterday did two appearances. So we recorded the weekly high performance physiology podcast, which I do with my colleague Rob Malseri, and we talked about straight shortening cycle. Very quick introduction to that. That'll be out in a couple of days' time. And then I did a webinar with the hopefully now famous coach Zia, and we talked about how to preserve muscle mass in a diet or caloric restriction. And that was good. So we did that as a live webinar, and we had quite a lot of people sign up, nearly 500, I think. But a lot of people obviously were hoping to just kind of get the recording. So we had, I think, maybe about 150 in the end who actually attended. And we're actually going to, I think, disappoint a lot of people, because while the recording will go out, it's not going to go out for a couple of days, if not a week, and it'll go out on YouTube. But we're not going to release the Q&A. We're only going to release the presentation itself. So as and when we do another one of these webinars, I would urge people to try and attend if they can, if they want to take part in that Q&A. And the Q&A, I think, actually ran for about an hour and a quarter in the end. So we did about 45. Yeah, we had a really great audience kind of response. We were talking about it afterwards when we did our little debrief. People were so, kind of interested in the material, super kind of respectful and kind, and kind of all those other good things. It was a great atmosphere. I was really pleased with the people that came on board. So thanks, guys, if you were part of that. We really appreciated you. And I would encourage people, again, as I said, if they want to be part of that and benefit from that, then please do show up next time, because we aren't going to release the Q&As as kind of video material. We're just going to release the edited version of the presentation. So yeah, it will be available, but not the whole thing.
How long was that part of the video?
So I think we talked on the presentation side for about 45 minutes. I mean, we had to wait a little bit at the beginning because there was a lot of people trying to get on to the webinar space. So I think we started about 10 past the hour, and then we ran nearly to the end of that hour, not quite to the end of that hour. So 45, 50 minutes, and basically just started with a quick representation of the stimulating reps model, because I think now that the stimulating reps model is quite mature, people have missed the point that it is unique insofar as it connects basic physiology with strength training practices, which had never been done before. People just kind of made stuff up and kind of drew lines and tried to figure out how things were working. It didn't really make any sense. Now we have direct lines between fundamental concepts like motor unit recruitment and Henneman's size principle leading through to actual training recommendations. Same thing with the force-velocity relationship, mechanical tension, sarcomatogenesis, passive tension, the basic fatigue mechanism, neuromechanical matching. All of that stuff is textbook physiology. I know that you've got influencers running around the internet claiming that neuromechanical matching is not a thing. But, those aren't people writing textbooks. We've got this stuff relatively well documented. It feeds through into training recommendations. So I started off explaining how that worked, and then I just went into the key material, which was working through 5 specific areas in which caloric restriction is going to have a negative impact, either direct or indirect, on the preservation of muscle mass in that period of time when you're preparing maybe for a bodybuilding competition. So went through those 5 areas in detail and explained just how they're working. We didn't go into absolutely every single detail. I mean, we're going to obviously do a little bit more on one of those areas today, but it was, I think, enough for people to understand the broad picture of how things are working. So hopefully people enjoyed it if they attended. Hopefully people will also enjoy it if they see the video of that specific presentation. But as I say, the Q&A was a great experience. I thought it was a really good atmosphere, really great questions. So again, thank you if you took part, if you're listening to this now.
Yeah. And like you said, stay tuned, because it will be up on YouTube if you did miss out in the next week or whenever you get it out there.
Yeah, absolutely.
So this is our I think it's our first part 2 episode. Perhaps we've done a couple on MPS and myofs, but that was sort of over time and sort of evolved. So this is the first time we've had a topic we've intentionally split over 2 episodes. So if you haven't listened to last week's episode, make sure you do. You don't technically need to in order, like this episode will still make sense, I assume, but it would be good to kind of get the full picture and listen to it. Now, I did explain last week that since our topic is all about sleep, there's not a whole lot of sleep related plans I could lean into from the Silver era. So I've just gone, last week I went with an athletic plan. This week, I'm going with something completely different. Well, I say different. It's kind of similar to stuff we've seen, but the reason I want to talk about it is a bit different. And this plan is coming from someone named Bill Pearl. Now, I anticipate a lot of listeners will have heard of Bill Pearl. And what's interesting about Bill Pearl is he won a lot of Mr. Universe competitions, but he started winning in the 50s and continued winning in the 60s and into the 70s. Now, for any astute listeners there, you'll know that this is the time period where anabolics started to be introduced. And so he really well sort of bridges this era of pre-anabolics, silver era, kind of coming into the golden era. Now, the other interesting piece about Bill is he publicly talked about his anabolic use. And so you can actually look up photos of, and I would encourage listeners to do so, of photos of Bill when he was competing sort of earlier on in his career when he wasn't using anabolics, and then look at later photos when he was winning in the late 60s and look at what his physique looked like at that point. And it's just an interesting case study in how even early anabolic agents, and obviously they've evolved a lot over time, but just seeing how that influenced people's physique at that point. So what I want to discuss today is a plan that he published. Technically speaking, this is after anabolics were being experimented with, but it is before Bill had been using them. So this plan was written in 1957. I believe sometime around 1958, 1959 is when Bill Pearl presumably started using anabolics. So this is, for all intents and purposes, probably still a pre-anabolic plan. Now, it is a plan that he published for others to follow. Okay. So this is not technically his training routine, but I think that we would be able to see some principles of how he would be training in a plan that he's publishing for others. So that is the plan today. And I don't want to give too much away. I'm going to sit in that, but it'll make sense why we might be talking about this at a later time. But let's talk about this plan now. So as is fairly standard, full body and done 3 times per week. Now, in some of these plans, when you see these in books or in magazines, sometimes what happens is the author might give people like a suggested starting weight to use. And obviously, even today, I get this question from clients like, hey, what weight do I use? And, obviously we sort of know a little bit more about it now. It's like, hey, I'm not going to tell you what weight to use. I need you to go to kind of, what your sort of strength level is. And, I'll tell people reps from reserve or whatever else. But often what they would do back then is they give people an idea of, hey, this is a starting weight. Okay. And then they would talk about how to progress it over time. But he did sort of give people a suggested starting load to use. And then he did talk about like how to progress that weight over time. And so the way that he talked about progressing that weight over time meant that essentially people weren't going to be hitting like a 0 reps in reserve or failure with each set each week. So there was like a progression model built into it. And a lot of the time they were kind of building in some of these progression models, but usually they were using like a double progression method. But I think it's important to note that they weren't generally just taking each set to failure. Yeah, when they were progressing load, they were often then keeping a rep or 2 reps in reserve. So this is done 3 times a week. And it's 11 exercises, which again is fairly standard at this point in time. I'd say maybe 12 exercises is potentially the norm, but certainly anywhere from that sort of 8 to 15 is very standard around this time. So we begin with sit-ups. Now it was sit-ups with feet elevated, and he did 1 set, 10 to 30 is what he suggested doing, and then moved into a leg press, doing 3 sets of 10. And then did a toe press on the leg press. So obviously, nicely convenient sort of set, sort of pairing there. And that was again 3 sets of 15 to 20 repetitions. Then a barbell vertical shrug, 2 sets of 10. A barbell overhead press, 2 sets of 10. Bent over 1 arm dumbbell row, 2 sets of 10. And then a wide grip bench with about 3 sets of 10. Dumbbell French curl, so seated. 2 sets of 10, seated dumbbell curls, 2 sets of 10, barbell incline press, 2 sets of 10, and then dumbbell flies, 2 sets of 10 as well. Obviously, I know you're going to immediately say that there's certain muscles that are getting much more work and certain muscles that are getting much less work, but I'll pass over to you. What do you see there?
Well, I don't think anybody's going to be surprised when I point out that there's no pull-ups or pull-downs in there. So there's no frontal plane pulling. But, giving props, there is a sagittal plane pull in the form of the bent over one-arm dumbbell row. And there is obviously the shrug. So it's not like there's no back work in there. It's just definitely, as you say, one of those muscle groups that does seem to be underrepresented. I do like, and this is a comment that I've made multiple times in similar programs before, I do like the fact that there is a variety of pressing of the kind that we need. So a lot of people will just throw in a bunch of pressing exercise variations, and it's like, well, are you really, kind of targeting different muscle groups with those choices? Whereas here, we've got a wide grip bench press, fantastic. And then contrast that with the overhead press, which is presumably behind the neck. So two very, very different, one frontal plane, one transverse plane. And then I'm guessing the incline press is probably sagittal plane. So, I think that's a really nice combination there. Obviously,
So in that combo there, so the incline, the wide grip flat bench, and then the dumbbell fly. So
yeah, of course, the flies as well. Yeah, I mean, I would say the flies and the wide grip bench are basically duplication. I don't think that's worth doing.
That was going to be my question, if you saw any value to that fly.
No, not really. I think the pressing variations is really solid. I like that a lot. The combination of those three, I think that's a really classic, kind of way of setting that up. That's something that I think is really worth considering in this kind of template. But no, I don't think the fly is adding anything really. But then he's just tacked on.
Is the fly getting potentially any more upper chest than the wide grip bench might be? I mean, obviously you're going to then have that covered in the incline. So there's between those two.
Only insofar as your recruitment might be slightly higher. I mean, obviously with dumbbells, you might have, if you've got a bit of a stability issue, you might lose what you think you're gaining. I'm not a fan of dumbbell flies because it's like, if you've gone to the trouble of doing a single joint exercise, because the purpose of doing that is to increase recruitment. That's why bodybuilders called, single arm curls concentration curls. It's because you're trying to essentially lock down your recruitment into one area. It's the same concept of going from multi-joint to single joint. So the whole purpose of doing a single joint exercise is to focus recruitment on one specific muscle. Then why would you then use an unstable load to do that? It makes no sense. You're losing the very thing that you're trying to gain. So you're much better off doing a fly in a machine context if you're capable of doing that. I mean, you might be too strong for the machine, I don't know. But, if that's a possibility, I would always do that. But yeah, I don't see the value in the fly, particularly in this context. I like the pressing combinations. In terms of the other stuff, I mean, obviously, for me, like a leg press as an option, it cuts down on the muscle mass that you're using. It's easier to warm up for. I'm as big a fan of the squat as many people are. The toe press on leg press is fantastic. Again, it's a great calf exercise. It's the one I would probably program if I was only programming one. Not quite sure what's going on with the curls. That seems a bit strange to me, but I mean, maybe you can shed some light on that.
On the lack of curls?
No, there's two different curl variations, but it's like, I mean, how are they different?
Sorry, I thought you meant leg. Okay, yes, because there's no hamstring work, obviously.
No, there's no hamstring, but then that seems to be like another one of those things. It's like, you could almost argue that bodybuilders at that time perhaps only thought they were ever going to be seen from the front because we've got no hamstring work and we've got no back work. So it's like, but that does seem to be an overriding tendency.
I must admit, I'm not actually that up to scratch with their, like in terms of what their posing routines would have actually been. And I do wonder if maybe there just actually wasn't as much posing or emphasis on the back. But I don't know, maybe I'm completely off the mark there. But it is definitely a pattern it's repeated. It's not just like an isolated thing we're seeing either. And I understand the hamstrings, obviously, in the absence of a hip hinge, there's not a lot they could have particularly done. But as you've pointed out many times, the back work, there was a few other options available to them. So yeah.
Honestly, there's no scenario in which you could argue that a deadlift isn't a possibility. So stiff leg deadlifts are absolutely a possibility for anybody with a barbell. And pull-ups, you can literally do that, almost anywhere. If you've got a little bit of engineering know-how, you can set up a station to do that. So honestly, I don't think that it has to be a non-practical reason. It's not like saying, look, there's no leg curl and there's no knee extension. Well, yeah, but they didn't have them, so they wouldn't be able to do them. It's not like saying that. It's actually saying that they chose not to do this stuff because they didn't want to do it, which is weird.
Yeah.
So, but anyway, what is the difference between a seated dumbbell curl and a French curl?
Yeah, so the French curl is triceps. So that's a seated overhead tricep extension.
Okay, I misunderstood then. So that isn't two separate curl variations. That is French. That's a French press more, or a overhead shoulder.
Yeah.
Overhead
so
extension.
good point. Yeah. So they called, I'm trying to remember the other name that they call these exercises, but a lot of the tricep exercises they were calling curls.
Weirdness.
Yeah, I think they just called them triceps curls, but I need to go back and double check. But yeah, it was definitely a labeling thing that shifted over time.
Okay, that makes a little bit more sense now. So, yeah, okay. Okay, fine. Yeah. Okay, so he's got two sets of direct arm work, triceps and biceps. Yeah, okay, well, that makes the program a little bit more well-rounded. And so, yeah, the things that are really missing then is just the hamstrings and the extra back exercise. So yeah, I guess if I were to modify this, I would take out the fly straight away.
There's obviously a big emphasis here on chest.
Yeah, I'd take the fly out and replace it with a pull-up or a pull-down if you've got a machine. I'd probably take the sit-ups out and replace that with a stiff leg deadlift. And that would probably be a program that I would probably do. I mean, for me, I would take the direct arm workout because I don't need it, but, other people will want that.
Yeah, if you made those little adjustments, there's not really anything you're missing, is there?
No, it'd be pretty good, actually.
Yeah, I'm trying to think if there's anything else I would change, but no, I think that's about it. Obviously, if you've got equipment nowadays, you've got a leg extension or something by all means, but given what they would have had access to at that point, I think that's actually quite good with those two little tweaks.
Yeah, totally.
It's interesting, the sets as well. So like, I'm just looking, he's doing a third set on a leg press and he's doing a third set on a bench, but everything else is 2 sets. And the leg press to me makes sense because that's the only exercise which he's getting for effectively it's basically his only lower body exercise. So that makes sense. And I'm guessing the bench is just because that must be his, I'm guessing, priority. So it's, interesting that there wasn't like this unanimous, we do 2 sets of everything or whatever. It's like, no, actually adding this third set maybe for high priority, but that's it. I wonder what his rationale was.
Yeah, no, I don't know. Yeah, it's tricky. I mean, it could be that, he's using a lot more weight on those exercises and actually he's thinking maybe that 3 sets allows for, just taking a little bit more of a build up to his top set. I mean, I don't know.
And you might be right there because he did actually add weights in successive sets.
Yeah.
So it may be that he's using that first set almost a bit like a warm-up set. And then that second set might be sort of 2 reps in reserve, and that third set, because again, he's adding weight each set.
Yeah.
And he's just building to that final set. So yeah, maybe that's all it is actually.
So yeah, no, I mean, another great example of a routine done, 3 times a week, full body, 10, 11 exercises, which, covers everything and is not a million miles away from what we would probably write. Just a couple of preferences in 2 places, really shift of preferences. Not perfect, but really very close to what we would say is physiologically ideal and a million miles away from what you see in the 80s, 90s and in terms of routines that are just utterly ridiculous. So, I think that's really cool. That's really cool.
Yeah. So part 2 on sleep.
Okay. Yes.
Where do we pick up?
So last time we talked about, we gave an introduction to the various terminologies that researchers use around sleep. So this is really that part of the last week's podcast, which will be beneficial. So if you're not familiar with what sleep deprivation is, what sleep restriction is, what persistent sleep restriction is, and those kind of terminologies, then last week's podcast will be definitely useful to you. Really, what I want to talk about, and last week the focus was how does sleep loss or insufficient sleep affect workout performance? How is it affecting you in terms of your ability to, kind of do what you want to do in the context of that workout? This time we're going to talk about how sleep affects atrophy, as in, does sleep loss cause atrophy? And secondly, as a kind of a carry on from that, corollary of that, how does insufficient sleep affect your recovery from a workout? And I'm actually going to show that those two things are actually quite closely related to each other.
And this is independent. So last week, obviously, we talked about the performance side.
Yeah.
So this is independent of the impact it's having within the workout.
Yeah, totally separate issues. So a lot of the time, what you'll find is that influencers will talk about these things separately. They'll say, does several bad nights of sleep affect my workout performance? Is it changing my ability to hit high levels of recruitment? Well, yes, it is. And you can hear us talking about that last week. Secondly, you'll also find influencers who will sort of argue and explain that sleep is a key process of the post-workout recovery kind of period of time. And again, I'll explain a level of detail up from what they're going to tell you in today's conversation. So basically, starting at the very beginning, and let me put this in context of the literature. There is in fact, relatively well-developed section of the physiology literature which deals with the effects of insufficient sleep on muscle loss. And it's mainly done in animal models, simply because obviously it's unethical to deprive people of sleep for long periods of time and then watch how it affects muscle loss. So, people will obviously jump around and wave their hands in the air and go, I'm going to ignore everything you're saying because I don't like the fact that you haven't got a study in humans. I'm like, okay, well, carry on doing what you're doing then. So we have got a lot, but it is a very well-developed area of literature, so there's some really good stuff. So I'd encourage people, if you're interested in it, to actually dive in and start reading some of that stuff. There's a lot there. The classic model is basically about sort of 72 to 96 hours of sleep deprivation in rodents, and you get some pretty meaningful muscle loss over that period of time. So definitely a very meaningful effect. The way that it seems to happen is because the sleep loss produces a stress response, and it's a pretty big stress response. We're not talking about a small increase in cortisol like you get after a strength training workout. So I'm already kind of predicting what the responses to this conversation are going to be online. People are going to hear me say the word cortisol, and they're immediately going to have a knee-jerk reaction that says, doesn't cause muscle loss after strength training workouts. I'm like, you're absolutely correct. The response is tiny. It's not a really big deal. And also you're in an anabolic state because you've just done a strength training workout. But when you have a large period of sleep loss, a couple of days of sleep loss, in animal models, you get a very, very pronounced glucocorticoid response, which is essentially telling you that you've got a major stressor in place. Now, the important thing to note is that you can find similar stress responses or glucocorticoid responses in other models. So you can find them in the animal models of a traumatic injury. You can find them in animal models of exogenous glucocorticoids, so essentially corticosteroids, the kind of anti-inflammatory that people maybe are prescribed after an injury of some description. So you can find, multiple models of those same high levels of glucocorticoid, and you can see essentially the same effects being reported across all of those models. In fact, you can go one step further than that, and this is where you can take things out of the animal kind of literature and into the human literature. You can find studies that have looked at essentially what's called hypercortisolemia in human situations. Now, these are not controlled trials because obviously you're observing something that's happened, usually by accident. So somebody has a traumatic injury, and you monitor them while they're being treated, and you get information that's then useful that you can then compare with other control subjects that you kind of select afterwards. So it's not a perfectly controlled situation because you're relying on the chance of somebody, kind of showing up with an injury that you can then, kind of benefit from the knowledge of. So what happens is somebody will come in with an injury, for example, and they will immediately experience a hypercortisolemia response as a result of that injury, and you've got them obviously in a hospital bed, and they stay there for a couple of days while they're recovering. So you've got this situation where they've got this person who's been injured and they're in a hospital bed, and you measure the kind of atrophy that happens over that period of time. And what you then do is you get a control person to go and sit in bed for the same duration of time. So you've got a trial, essentially, where you've got one person who's got a traumatic injury and in bed, and another person who's just in bed for the same period of time. And what you notice is that the atrophy is a lot faster in the person who's got the injury compared to the person who hasn't. And it's basically because of this cortisol-induced effect. So it's like there is a place that you can go to in the literature and you can see this effect happening. It's just a little bit of a weird kind of experimental model because we can't replicate that very easily.
So presumably in these models, these participants, like they're still eating over this time, like there's
totally. Yeah. So you've got a sort of feeding control situation, but basically you're monitoring the effect. Now, this is something we're going to come back to and do a podcast on in the future, but I'm going to mention it now so that people have this in context of me explaining this. But if you compare the muscle protein synthesis rates and the muscle protein breakdown rates of somebody who is in bed, both rates are actually very, very low. One of the things you notice about bed rest is that not only does muscle protein synthesis come down, but muscle protein breakdown decreases as well. So you've actually got very little turnover in total of synthesis and breakdown rates. If you look at somebody in bed with traumatic injury, MPS and MPB are both off the charts. It's ridiculous. It's like if I just took the top line and looked at MPS, you would think that they were in a highly anabolic state compared to someone in bed rest without the traumatic injury. And this is the thing that I keep going back to, and people it's like I say it and people kind of look at me as if to say, did you really say that? And I'm like, yes, I did. If somebody has an injury, their MPS goes off the charts. It jumps really high. And that's because MPS is used for damage repair. But at the same time, you've got even more breakdown going on and you're actually atrophying. So this is the nonsense that some of the hypertrophy researchers have managed to tangle themselves in at the moment, because they're like, oh no, every time MPS goes up, that means we're in an anabolic state. You can't possibly lose muscle. And I'm like, let me introduce you to poor Mr. Smith, who's sat in a hospital bed, who's just had an injury, and his MPS is off the charts, and he's atrophying like crazy. Are you really serious telling me? Oh, no, we don't mean that. That's different. I'm like, no, it's not. It's physiologically the same situation. You've got damage repair happening at the same time as you've got atrophy happening. You've absolutely got an anabolic response happening to produce this damage repair, but you've simultaneously got a breakdown effect that is causing you net protein degradation. So the thing is that you can have these situations where you've got, as I say, in bed rest normally with no injury, very, very low MPS, very low MPB. In the case of traumatic injury and bed rest simultaneously, you can get very high MPS, very high MPB, but the MPB is bigger, and as a result, you're in net protein loss. You're actually atrophying over that period of time. Now, interestingly, you can experimentally replicate that identical situation with somebody in bed rest if you start giving them exogenous glucocorticoids. So you create experimental hypercortisolemia, essentially, without needing to go down the route of, kind of waiting for somebody who unfortunately gets injured and trying to take advantage of that unfortunate circumstance. You can actually just experimentally create high levels of glucocorticoids by, the application of a corticosteroid, and you get exactly the same effect. Immediately, MPS jumps up and MPB jumps up as well, and you end up with this higher turnover, but net protein loss as well.
So even without the injury, you're still seeing MPS go up.
If you impose a glucocorticoid response, you get the same effect. So it's showing us that it's not the injury itself that's creating the issue. It's the glucocorticoid response to the injury that's creating the issue.
Yeah, that's interesting, because I assumed it must have been the injury itself. But yeah, obviously given that, it's telling us it's not. So do you want to just, in case anyone's not aware, you've mentioned muscle protein breakdown, you've mentioned MPS, muscle protein synthesis, and you've alluded to the balance between those two being important. Can you just sort of elaborate on that briefly?
Yeah. So every muscle fiber in the body is always in a state of flux. You're always, the proteins inside the fiber are not constant. They're not immortal. What you've got is a constant state of rebuilding and destroying, rebuilding and destroying. And so ultimately we've always got a balance between the rate of synthesis, construction of proteins, and the rate of degradation, destruction of proteins. So if you increase synthesis more than you increase breakdown, if you increase both synthesis and breakdown at the same time, in the same amount, nothing happens. Your flux increases, but your actual content of the protein in the fiber, the size of the fiber, stays the same. So you could get if you had an incredibly high rate of flux, you could end the day with a totally different set of proteins inside the fiber from when you started the day, but your size of the fiber would be the same. So you have what I would call changes, but no change in size. If you change the balance between synthesis and breakdown, then you end up with a shift in one direction or the other. Now, what we're trying to do is change the shift so that synthesis increases more than breakdown.
So maintenance, as we go back one step, so when people talk about maintenance, they're not saying that the muscle itself is not changing, that there's no change in contractile proteins or anything. They're saying that there's an equal balance, I guess, of building and losing.
Across a period of time, and during that period of time, you're going to have periods when synthesis is higher than breakdown. You're going to have periods when breakdown is higher than synthesis. If you have, say, a 3-day period of time, or let's just go with the classic maintenance literature. You've got a week period of time. You do 3 or 4 sets on Monday. You come back the following week and do another 3 or 4 sets. And you're in maintenance of muscle size over a 6-month period of time, which is what the literature shows. Each week, you're going to have synthesis elevated above breakdown rates for the first maybe 48 hours past the workout. And then for the remaining 5 days of the week, you're going to have breakdown above synthesis because you're going to be in essentially net protein loss for that back 5 days. And that back 5 days is going to equal more or less protein loss of what you gained in the first. So even within like maintenance is never really going to mean that synthesis equals breakdown ever, really. It's going to mean that for some periods of time over the week, you're going to be a bit more synthesis, a bit less breakdown. The other period of time, it's going to be the opposite way around. Obviously, for strength training progress, we want to be constantly with a little bit more synthesis over breakdown. But this has been an obsession by the hypertrophy research community on synthesis, and they're just trying to ignore breakdown because it's hard to measure. And they're like, we're just going to forget about it. And I'm like, if you look at the injury literature, you can see massive jumps in MPS at the same time as massive jumps in MPB. It's about balance. It's not about one or the other. And the interesting thing, though, is that when we talk about stressors of major magnitude, I'm not talking about having to go to the shops twice a week instead of once. I'm talking about actually a major stressor like an injury or severe sleep loss for multiple days, something significant, substantial. Then you're going to see a big glucocorticoid response. You're going to find that you start to get these elevations in muscle protein breakdown occurring, which is going to start atrophying the muscle fibers directly. Now, the really cool thing is we actually have a distinctive process that's been identified for how this works. So we know that the glucocorticoid stimulates receptors of those glucocorticoids in muscle fibers, and that triggers a number, at least 3 pathways have been identified, including the mitochondria themselves, which then stimulate an elevation in reactive oxygen species, oxidative stress, inside the muscle fiber. So we've got a very clear set of, I've got a clear pathway, a map, to show how the glucocorticoid response to the stressor, which is a very well-documented phenomenon, that doesn't need defense at all. So we've got stressor leading to glucocorticoid response, leading to oxidative stress, as I say, by 3 separate pathways, including mitochondrial kind of activities. And the oxidative stress then leads to an increase in the muscle protein breakdown rates above and beyond what we would typically expect in that given scenario. Now, the reason we know that it takes that route is because if you go and experimentally produce a glucocorticoid response in the muscle, however you do it, there's a number of experimental models can do that. The classic one is just exogenous glucocorticoids. You just inject with corticosteroid. But you can also do it with heat stress. So you just raise the temperature slightly for a day or 2 and you get the same kind of effect. So it is a genuine stress response. I'm not saying, all these experiments are done with just synthetic glucocorticoids and therefore people go, oh, well, yeah, but that's not the same. Yeah, you can create the same effect with a heat stress. You just raise the temperature a couple of degrees, you're going to get the same problem. So you can actually create this endogenously as well as exogenously. It doesn't differ. If you go in after having done that, so you measure this kind of atrophy occurring as a result of the glucocorticoid-induced oxidative stress producing muscle protein breakdown, producing atrophy. If you go in and you actually now stop the oxidative stress from happening by maybe some kind of antioxidant, maybe you use vitamin E or something, like in an experimental model. You go in and you do that, it actually stops the atrophy happening. So we've got this really nice documented flow of events from stress to glucocorticoids to oxidative stress to muscle protein breakdown to atrophy. This is really well done. This is not like, kind of a lot of the hypertrophy research where they're like, we can see MPS increasing. Oh, therefore we're going to now invent an entire scheme of how hypertrophy works and how, volume is amazing and all this kind of. This is really good data-driven analysis. This is like people who've gone through very carefully and gone, oh, look, sleep loss creates a glucocorticoid response and it also produces atrophy. Maybe there's a connection between those two. Let's piece this together very slowly and carefully until we figure out how it's working. And they go, okay, so we've got stress, glucocorticoids, oxidative stress, reactive oxygen species. We've now got a pathway, 3 pathways by which the glucocorticoid receptor starts to trigger that oxidative stress inside the fibers. Look, now we've got a way to block the oxidative stress and stop the atrophy happening. And oh, look, the muscle protein breakdown is the pathway by which the oxidative stress is causing the atrophy. It's very, very, very well done piece or set of studies. So I think this is much more confidence in this than I've got in a lot of the hypertrophy stuff, to be honest. This is really good work.
I'm sure people listening to this are thinking, well, hang on, then can I just use some of these antioxidants and mitigate some of that effect?
You have to bear in mind, the animal models are designed to find mechanisms. They're not designed to find you ways to deal practically with solutions. With your problems of sleep loss. This is me describing how researchers have discovered the mechanisms by which sleep loss causes atrophy. This is not me at all saying, what strategies might be appropriate in cases of insufficient sleep.
And there could potentially be drawbacks from pursuing a strategy like that anyway when it comes to potentially using antioxidants to try to mitigate some of that effect. Obviously we're not making a comment on that, but I just kind of want to put out there that, hey, that doesn't mean that the solution to this is go pump yourself full of antioxidants and see if you can mitigate any downside. It may not be as simple as that.
Yeah. And and there's other stuff going on there as well, as we'll come to when we talk about the effects of glucocorticoids on recovery, because again, that's one of those areas probably that is going to be conflicting with what we're saying here, but I'll come to that later on. But in terms of just squaring the circle, what I've described here is the standard hypothesis or hypothetical mechanism for how sleep loss is producing atrophy in humans and animals. As I was going through the literature, I noticed an interesting set of observations which I think support this model that don't often get talked about, together. So I just want to kind of list them out together and show you as an audience why I think this is a really solid model. If you look at the standard ways of causing atrophy in any animal, the 2 standard ways of doing it are immobilisation or caloric restriction. I mean, that kind of is, the really basic, and you might argue natural ways of kind of making this happen. The kind of situation, it's like we're not imposing stressors here. We're just, kind of watching what happens when an animal doesn't have quite enough to eat or it's not moving around so much. Nothing scary. If you look at those situations, you see a distinctive pattern of how the atrophy is happening. If you now look at the stress-induced muscle loss, you actually see very big differences across multiple areas. So firstly, one of the most striking things you see about glucocorticoid-induced muscle loss is it's very, very much a type 2 muscle fiber phenomenon. If you look at the muscle loss that happens during caloric restriction or immobilization, it's not. It actually affects type 1 and type 2 fibers. Now, if you don't understand what you're looking at, you can get yourself in a knot here. Let me just explain why. So a lot of animal models will use caloric restriction, and then they will notice type 2 fiber preferential atrophy. Now, the reason that's happening in the main is because if you imagine you've got an animal or 2 separate groups of animals, a control group and an intervention group, then one group is, the intervention group is eating slightly less maybe, and the control group is eating normally. What you'll find is that the intervention group will either lose weight or it'll maintain weight, and the control group will obviously gain weight. Now, what's going to happen is that because of the weight difference, your normal physical activity is now not going to reach the same level of recruitment as it did previously. When we've talked about this with older people, and if you have an older person who gains body weight, they're going to start using their leg muscles to a higher level of recruitment than they were previously. If they lose body weight, they're going to stop using their upper body mass just in an older person who's not doing
you see this with the weighted vests. You've seen those studies where they have older participants wear weighted vests, they gain muscle in the lower body.
Yeah, you're not controlling physical activity levels for recruitment levels in those situations. So you actually find that if you take an animal model and it loses weight, it will stop using its high threshold motor units to do its normal activities. It doesn't need to anymore. So you lose muscle size in those fast-twitch fibers. So you actually, if you don't know what you're doing physiologically, if you don't have a model of how physiology is working, you are going to look at those caloric restriction studies and you go, well, no, I've got these caloric restriction studies that show, preferential type 2 fiber loss. You're wrong. I'm like, no, I'm not. You just don't understand what you're looking at. You actually have to understand how physiology works if you want to interpret those studies correctly. So generally speaking, if you look at controlled situations, you'll actually find that type 2 and type 1 fiber size decreases largely in proportion with fiber size, like we talked about in a previous podcast. So it's generally speaking a size phenomenon, not a type phenomenon. In contrast, glucocorticoids aggressively goes after, or more accurately, type 2 fibers are much more sensitive to the glucocorticoid problem than type 1 fibers are. So there's that in terms of size changes. So you see a very, very big difference in that respect. In contrast, second observation, you actually get, weirdly, quite a bit of muscle damage in the slow twitch fibers after glucocorticoid applications, which you don't tend to see in immobilisation or caloric restriction. So there's this weird kind of damage effect going on, probably the oxidative stress generating some interesting effects, maybe because there's a lot more mitochondria in the type 1 fibers, so you get a lot more oxidative stress through that pathway. Who knows? But there's an interesting feature there, and it can be really quite pronounced. It actually starts to look like incomplete muscle damage repair in those situations, which is very, very weird. So there's that marker, if you like, which is unique to glucocorticoid, which you don't see in situations of immobilisation so much, and certainly not in caloric restriction. Thirdly, I've kind of made a point quite a few times that you can't just eat a ton of protein and stop muscle atrophy happening. It doesn't work. It's like, protein on its own, dietary protein on its own doesn't change anything in terms of atrophy rates if you're just, creating the atrophy by a reduced activity level or caloric restriction or something like that. In contrast, there do look to be a couple of dietary interventions that might influence the atrophy caused by sleep loss. For example, dietary leucine seems to have a little bit of a ameliorative effect, if that's a word. It doesn't. It kind of preserves a little bit more muscle mass in the context of sleep loss induced atrophy, whereas that doesn't really work in the classic immobilisation or kind of caloric restriction induced atrophy situation. And then, of course, finally, something I've already mentioned, if you compare what happens during immobilisation and caloric restriction, which is predominantly a reduction in MPS, you don't really get a big jump in MPB in caloric restriction unless you go crazy with it. You do, and you don't get that with immobilisation either. You do get this huge increase in MPB with glucocorticoid situations, whether it's sleep loss, stress, traumatic injury, exogenous glucocorticoids, you name it, anything, they all create the same effect, which is a big jump in MPB. So really, for me, when I look at this picture, I've got these distinctive characteristics of glucocorticoid administration or generation, whether it's exogenous or endogenous, doesn't really matter, which are unique features of the atrophy that's happening that are shared across all of these scenarios. So again, not only is the literature base itself really solid and the model and the investigative processes have been really well done, not only that, but when I come to it as an intuitive kind of investigator going, does this make sense to me? Can I see the same features that are occurring across all of these situations? And can I see those features being different from standard immobilisation or caloric restriction induced atrophy? Yes, I can. So that gives me a lot of comfort that I'm seeing something that is a repeated phenomenon that is consistent across all of these situations. So that, for me, gives me a lot of confidence in saying I think this model is probably correct. I think it's a really well-constructed model, and they've done a really amazing job of pulling this together.
Do you know why the leucine seems to have a bigger impact in?
I knew that question was going. No, I don't. I mean, that's kind of like, and I had a lot of nutrition questions on the webinar yesterday, and I'm just like, I don't want to fall into the trap of, there's I don't know if you ever saw the film Patch Adams with Robin Williams.
Yeah, ages ago.
Yeah, co-starring Philip Seymour Hoffman, which was one of my favorite actors. Very sad when he died. And they play off each other fantastically in this film. It's such a great kind of conflict that they managed to, or conflicted relationship that the two of them have. There's this scene where essentially Philip Seymour Hoffman's character is just assuming that Patch Adams can't possibly, kind of beat him in the examinations and the scores that they get, because he never sees him working. So he kind of just doesn't really understand that this guy is a genius and he can literally understand all this stuff and basically just not do any work. Hoffman's character is working his, posterior surface off and not managing to kind of get to the same level of success as Adams is, or Robin Williams' character is achieving. So I don't want to be that guy. I don't want to be the Hoffman's character, and I don't want to be the person who goes, I can't do it, so nobody else can do it either because I'm the cleverest person ever. I don't want to be that person. All I can say is that I know what my limits are in terms of being able to get my arms around an area. My limits for what I can get my arms around are limited to muscle physiology. If I start pushing out into systemic physiology or too far into nutrition or anywhere outside of what I'm super comfortable with, I'm going to start making mistakes. I'm not saying that there isn't a Patch Adams out there who can do that. Maybe there's somebody else who can do everything I do, plus they can do nutrition, plus they can do, kind of natural health, plus they can do X, Y, and Z as well. Maybe they can, but I can't. I can only do what I can do. So I'm not saying other people can't do that, but I do know that my capacities are limited to addressing muscle physiology and nothing more. So when people start asking me questions about nutrition and systemic physiology, I'm like, I have to draw a line here and say, I can't give you the expert answer on that. I can only give you the expert answer on this area that I'm super confident of. So I kind of just have to say, I don't know why that's happening. And I'm probably never going to know why that's happening. Because
at a super basic level, are we seeing MPS go up in those models?
So I don't think there's been any more than 2 or 3 studies done on this. As far as I'm aware, the literature extends to showing that this happens both with exogenous glucocorticoid production and also with sleep loss. Yeah. So what I'm saying is you get the same atrophy effects in both of those situations, and you get the same kind of helpful effect of leucine in both of those scenarios. When I look at immobilisation and caloric restriction, I don't see the same benefit. So it just is one of those things where I can kind of go, I think this is an interesting feature that for me gives me confidence that we are dealing with a unique phenomenon here, which is, kind of you can draw a circle around and go, anything that produces a major stress response like sleep loss, severe trauma, anything like that, you're going to get a unique atrophy effect, which is going to have a certain set of features, and it's going to be produced by an increase in muscle protein breakdown rates. And the important thing here is that, and we'll cover this in a future podcast when we talk about caloric restriction in more detail, but I don't think you can rescue this with strength training. So when we talk about caloric restriction or immobilisation situations, and you talk about a suppression of MPS gets suppressed, you can rescue that by inserting a strength training workout every 48 hours. So you don't get a problem from the MPS suppression that you're experiencing. You can get back above baseline by doing a strength training workout. I don't think you can do that with this atrophy induced by glucocorticoids. I think that if you have this problem, your strength training workout is literally not influencing it at all.
Well, that was going to be my next question is contrasting those two scenarios and what does that actually mean from a practical standpoint? And even the example you just gave there, because there's studies where they will have people who will be, whether that's immobilization or bed rest or whatever, and they'll do a strength training workout before that period of time. And then you see that it'll mitigate atrophy for, 5 days or however long it is,
hours.
But then...
No, 48 hours.
No, I'm not saying that. No. What I mean is the effect of being bed rested for that 5-day period, I think that workout beforehand, doesn't that mitigate at the end of that 5-day period, they haven't lost any muscle because of that that workout before that time period?
It's 2
You know
days.
what I mean?
The 5
2
days.
days?
The 5 days. There is still muscle loss at 5 days. Yeah, they took 2 measurements. So the study you're thinking of, they had a measurement at 2 days. And I think they had a measurement at 7 days.
Okay.
You get atrophy not happening at 2 days. You do in the control group without the workout, and at 7 days you see similar atrophy. It's a little bit worse in the group that didn't do the strength training workout, but it's still pretty meaningful. So what's happening is you get about 48-hour protection. I don't think you get much more protection after that. But yeah, I mean, that's the point I'm making. You get protection by doing strength training from immobilization or caloric restriction situations, as long as they don't turn into stressors. But you don't, I don't think, get that from sleep loss. So I think if somebody is in a sleep loss situation, what's going to happen? And just to be clear here, if somebody gets a study and they're like, oh no, I looked at this sleep-deprived or sleep-restricted group of people and strength training still pushed MPS up. And well, yeah, we'll do. But you're not doing anything about the MPB situation. And that's still going to be, kind of exacerbated by the presence of that glucocorticoid response. So ultimately, I think the strength training is much, much better at dealing with problems of immobilization or caloric restriction. It's really not anywhere near as good at dealing with this glucocorticoid problem. So, of course, all that means is don't have the problem. I mean, I've probably said this so many times about all kinds of things, but it's like people are always asking me, oh, well, how can I recover faster from this workout? I'm like, don't do a silly workout.
Don't create the problem in the first place.
Don't create the problem in the first place. That's really what we're talking about here. This is one of those situations where this is a dragon you don't want to antagonize. Don't take that battle. Don't fight that.
So there's ways to mitigate the effect of the reduction in MPS, but ultimately,
I think there is
that increase in the muscle protein breakdown, that's the
much
bit that
harder
we don't.
Much harder to influence, I think, yeah.
So what would that mean for an individual who were, say, chronically undersleeping and they were still training as normal? So you've got one individual who's training full body 3 times a week and they're sleeping just normally, just fine. And you've got another individual training full body 3 times a week and they're always getting 4 hours of sleep. And that obviously accumulates over time. What, in a general sense, it's mainly that they're just going to be stimulating less muscle growth on a workout by workout basis?
No, okay, so...
Well, in the sense that like net hypertrophy.
Exactly. So, yeah, in terms of the actual stimulus, it's not going to be affected. I mean, obviously, last week's podcast still applies. You've got sleep-induced effects on the workout performance, reduced recruitment, reduced motivation, all that stuff. But in terms of the fibers you actually stimulate, no effects. You're still going to get a bump in MPS. It's still going to do its thing. What you're just finding is you're running with a constantly higher level of MPB going on in the background. So you're basically just kind of running through treacle. You've got a hole in the bath of water that you're trying to fill. You're constantly just seeing all this good stuff just disappearing all the time.
So if you were to plug, not that you'd be able to, but if you were to look at the weekly net stimulus table, or what do you call it, the website you've got up?
Yeah, you would have to accelerate atrophy rates. You would have to have a bigger atrophy component in the model. Yes.
Yeah, interesting. And so if you were to have that, I'm just thinking, if I'm visualizing the weekly net stimulus and thinking, okay, well, what does it mean if that atrophy rate is higher? Ultimately, that would suggest that we would want to train, like frequency is probably going to be the most important part of that equation then.
Yeah. So, if somebody were to say that they have a sleep problem and the first question I would ask is, okay, so please give me a list of everything that you are currently doing to address that problem before I go any further. It's like if they come to me like, oh, I'm not doing anything to address it. I'm like, well, go. That's your priority. Stop talking to me and go and find somebody who can help you. Like if they're actively addressing the problem, they've got a plan in place. And all they're asking me is, how do I mitigate losses in muscle mass while I am solving my problem? Okay, fine. I can answer that question. It would be like, I would look at a minimal volume workout, either 3 times a week or every other day. So it would not look different from my standard recommendations to everybody else. The only thing that I would modify would be that I would actively encourage them to do the minimum possible volume on every exercise. So they would be doing single sets and probably leaving a rep in reserve for the reasons that we're going to talk about in a few minutes when we talk about post-workout recovery being affected by sleep restriction as well.
It's interesting what you said there, obviously, is very similar to not just normal recommendations we might give, but in particular, the specific recommendations we gave 2 episodes back, I think it was, when we were talking about older adults.
Yes.
And like you said, that might become clear in this next bit you're going to cover.
Yeah. But before I move on to that, I just want to cover one observation, which is, I think, very important, because you're not going to see anecdotal reports from people who are using anabolics of this nature. So if somebody is using anabolics, they are not going to have these problems, because essentially the key factor relating to what's happening here is the balance between the anabolic and the catabolic hormones. So if somebody so as we've talked about before, if somebody's using anabolics, it has very minimal impact on the actual workout that you're doing. What it does do is bump up your natural levels of MPS relative to MPB. So if you imagine you've got somebody who is a natural athlete and they're ticking along and they've got a workout creating a bit of hypertrophy, and then they lose a little bit before they do the next workout with atrophy. What's happening with steroid application, anabolics, is that you just push the MPS up constantly a little bit higher. So you're constantly gaining muscle mass in the background. If you now have somebody who's using anabolics and they're simultaneously experiencing sleep loss, that cancels each other out. So your extra MPS is now balanced by an extra MPB. So you're going to find that people who are using anabolics while they're preparing for a bodybuilding competition, and they go, oh yeah, my sleep was terrible, but it didn't stop me from getting in condition. I'm like, you're not joking. Because that's how it works. Because you've got you can literally consider glucocorticoid issues, sleep loss, traumatic injury, stress, that kind of stuff, as being a mirror image, catabolic, because they literally are a corticosteroid. It is a mirror image of anabolics. You're literally doing exactly the opposite thing from what you're doing with an anabolic. So if somebody is on anabolics of any kind, even, probably TRT, and they're kind of going, oh, no, sleep loss doesn't affect me. I'm like, not kidding. It won't do.
It'll affect them as much as
they
would
your
still
workout
get better
performance
results.
And they'd still get better. Yeah, but they're not going to experience that atrophy that occurs from sleep loss. They're not, because they've balanced it out with the anabolic steroids that they're taking. So again, it's like obviously we kind of all know that fitness industry is, kind of knee deep in anabolics. It's an open secret, but a lot of these people are going to be responding to this podcast going, oh, no, it's not a big deal. I've never had any problem. I sleep really badly. Like, no kidding. Not surprised. So again, it's like one of these things that, in this podcast, we talk about silver era pre-steroid stuff. We're trying to get to the nuts and bolts of what actually happens physiologically in human beings without the application of steroids for people who are interested in that and how it works. This is why you're going to see a discrepancy between sleep loss in natural athletes and sleep loss in competitive bodybuilders who are using anabolics. You're going to see or our fitness influencers who are using anabolics. They might not even be competitive bodybuilders. The point I'm making is that you can consider this as like a mirror image concept of saying, like, on the one hand, anabolics are doing this constant elevation in MPS, constant growth in the background. Corticosteroids are doing the opposite. Glucocorticoids endogenously are doing the same thing opposite. They're creating a background MPB effect, which is going to gradually create atrophy across the board. So it's a really nice sort of symmetry there. And you end up just cancelling each other out, really, if you're in a situation where you've got, somebody who's experiencing both of those things at the same time.
And then I guess presumably anything that's causing that reduction in MPS, obviously that's not being cancelled out in the same way, but is obviously being mitigated against by someone who is using anabolics. So obviously like the dieting example, then you've kind of got that extra add-on on top anyway.
Yeah, sure. So that's all I had to say about the atrophy side of things. So I'll move on to recovery unless you have any other questions you want me to answer.
No, I think do the recovery and then we'll see if there's how we can tie it all together at the end.
Cool. So basically, there's two things to consider here when it comes to the batch of glucocorticoid inducers, whether it's sleep loss, stress, whatever. Essentially, on the one hand, you've got a suppression of MPS. So straight away, and actually a suppression of mTOR signaling as well. So straight away, you kind of know that you're going to see a slower rate of muscle damage repair because muscle damage repair depends on MPS and mTOR the same way that hypertrophy depends on MPS and mTOR. So, this is why I wanted to cover recovery at the same time as covering, kind of atrophy, because it's essentially the same, channels getting you to the same place. Interestingly, in the webinar yesterday, a number of people were coming up with, analogies to try and explain this to other people in the chat. So, for example, one guy said, well, can we think of this as like economic activity? maybe, like you might find that the economic activity of a nation or a state or a place, measured by GDP is really high. But actually, that's because they had a natural disaster and they had to spend an enormous amount of time repairing all this stuff. But they didn't. That's not economically productive because you're just repairing what you've lost. So you're just getting yourself back to square one. Whereas the other part of the GDP could actually be building robots or something. I mean, like you got to look below the surface and go, what is actually? I thought it was a really interesting analogy. It's trying to get, show people that, getting yourself back to square one after a disaster is not the same thing as building new stuff. You're not changing things. So same thing with hypertrophy and muscle damage repair. You use mTOR and MPS to get you to a repaired fiber, but you also use it to get you to a new size of growth of the fiber. Almost indistinguishable, if not indistinguishable, with our current technologies. And there's various analogies you can use, but I thought that was pretty cool, and I didn't think of that. That was in the chat, in the conversation yesterday on the webinar. So that's another reason for people to attend and actually listen to these, sort of backwards and back and forths that we're sort of getting in these webinars. First things first, you've got a slower rate of muscle damage repair. Secondly, and this is the interesting bit, we were talking about this before we came on the podcast today. If you look at the way the inflammatory process works in the post-workout period, glucocorticoids change the shape of the curve. So in a sort of situation where you haven't got the glucocorticoid, what you get is a relatively big spike in inflammation, 24 hours post-workout, that then goes away again fairly rapidly. If you look instead at a situation with glucocorticoids, what you get is a much smaller spike that lasts a much longer period of time. So you squash the inflammatory response and you spread it out over a longer duration, which is exactly what the intention of exogenous glucocorticoids actually is. It's like we're trying to suppress inflammation because the inflammation itself has got to the point where it's problematic. So that's why you'll generally find people take those things. Well, not generally. It's one of the reasons why people, be prescribed those kind of things is because they're trying to create a suppression of the inflammatory response, which is creating other issues secondary to the original problem. But in the case of endogenous glucocorticoids, you get the same effect. You get this suppression of the peak and a longer duration of the cortisol or whatever response, and also of the inflammatory response, and also therefore of the repair processes. And as we were talking about before the call, it's actually the same phenomenon that you see in older people. So older people have a slower, longer inflammatory response. Their muscle damage repair takes longer. Again, dysregulation in respect of that repair process. So that is why, basically, those two reasons are why you're going to get slower recovery from your strength training workouts when you have insufficient sleep in the back.
So if you were to have, let's talk from a practical standpoint here. So let's say, I gave the example before, you've got two people following a plan, one person sleeping adequately, one person's sleeping 4 hours a night or whatever. So you've mentioned, okay, what we would want to do is look at reducing volume down to perhaps just one set per exercise or per muscle, potentially keeping a rep in reserve if that was necessary as well. And that's going to speak to the recovery issue you've just identified there. So yes. It's not that we necessarily want to cause less of a stimulus. It's that we're just trying to mitigate, hey, this recovery is potentially going to blow out and then you're not going to be able to train again 48 hours later.
Correct.
So that's one adjustment that one person, again, obviously the best adjustment here would be to actually look at how do I make my sleep better. But, if that, for whatever reason, that was not happening, then in terms of adjusting the training plan, that would be one thing that someone would look at doing. Obviously, all the other factors around muscle damage is going to apply here as well, yeah? So we're going to look at total repetitions. We're going to look at muscle positions in the exercise, all this kind of stuff that we would have talked about a million times, yeah? Is there anything else specific from a workout perspective that you think would be worth adjusting?
So any of the variables that affect post-workout muscle damage are going to be relevant. So there's 5 key variables. So obviously, volume is one we've already mentioned. We've also got rep ranges. So if your rep ranges are creeping upwards, then, you could dial those back a little bit to heavier loading. You could also leave a rep or 2 more in reserve. So proximity to failure is worth looking at. And then, of course, you could look at your eccentric phases, normally doing slow ones or anything like that. And then stretch positions. So, can you consider whether that's super necessary to include super stretch positions in everything you're doing? Honestly, most people aren't going to change much of that stuff. It's mainly going to be the volume, maybe a rep in reserve extra from what they're normally doing, and maybe they might just kind of take the top end off their rep ranges. If they're drifting up towards the 10 and 12 end of the rep range, maybe they just kind of push it back down towards the 5s and 6s and 7s. But other than that, I think really volume is the key thing that is adjustable in those situations.
It's interesting. I actually get this question relatively often from people who are, maybe going through busy periods at university or school or college or whatever, or maybe with work. And one of the observations that these people often make is that they're unable to maintain the same amount of volume per exercise, not necessarily per workout, but, per muscle.
Yeah.
And generally what I hear people suggest in terms of I'll get the client feeding this back to me and they'll be like, okay, therefore this is what I want to do. And the suggestion they come up with usually is I want to drop off a workout. I want to keep the same volume I've been doing, but I want to drop down to 2.
You're trolling me now, aren't you? You're deliberately trolling me because you know that I'm going to.
Well, yeah. Okay. So give it to us. What's your response to that?
So reducing frequency is absolutely not the right answer. I would always reduce workout volumes. Even so, I've got no problem with people doing 2 workouts a week if they're super busy. And if you got loads and loads of stuff on, I would always, first things first, get the workout volumes right back to even single sets. And if that is too much still, then 2 workouts a week with single sets is still okay. Still move forward with that. But I would never jump straight away to the reduced frequency option unless the complaint is not really about recovery. It's actually about scheduling. If the complaint is about scheduling, then that's irrelevant. We're not describing a problem that relates to workout recovery anymore. What we're describing is a problem that we just can't fit the workouts in the week. So if the person is going,
sure,
I literally can't fit 3 workouts in a week, well, then we're not having a conversation about physiology anymore, are we?
No.
But if the conversation is about physiology, then it's always go from higher workout volumes to smaller workout volumes and keep frequency at 3 times a week or every other day, whatever you're doing. And then if that's not working and you're still not recovering, fine. Then you can drop back 2 times a week. I actually really like 2 workouts a week with single sets for, the extreme ends of the spectrum. People are really, really, super busy and can't do anything other than just what they can literally run into the gym and do and then run out again. And for older people who've got all the time in the world but just can't recover. I think that's a fantastic solution for both groups of those people. But it's not the one I'm just going to run to straight away. I think standard 3 times a week single sets is great.
Yeah. It is interesting how much of an impact this can theoretically have on someone. And because we're not just talking about one's natural ability to recover. Yeah, obviously there's some people like, you recover slower, you recover faster, or whatever. And we're not talking about that. We're talking about actual change within that individual. Because again, I'll hear this from clients where they'll be like, look, during these periods of time, I'm fine. I'm recovering just fine. I'm able to do the 3 sets per exercise, whatever. And then those same people will tell me over a semester or whatever that they simply can't recover anymore. And people, I think, underestimate the impacts on this stuff can have. I'm sure you've seen this study, it was in undergraduate students where they got them just to self-assess their stress levels. And then they got them to do, it was high volume. It was like 7 sets of 10 on a leg press or something like that. But they measured recovery. And they found that those who were assessing themselves higher stress levels it was like, I think, 72 or 96 hours to recover, whereas generally those who were self-assessing as low stress levels were recovered, I think, 48 hours later. Now, obviously this is self-assessment and whatnot, but
you can get the same thing in rodents. You can get the same thing in rodents without self-assessment. Because in experimental models of rodents, you can actually stress them out.
Yeah,
it's considered ethical to do that. So they're allowed to impose a stressor on the rodent for a period of time, and then have an exercise-induced muscle damage protocol, and then measure recovery after that protocol, and you get exactly the same effect. Self-assessment is not a limiting factor here because we see the same thing without it.
Sort of timeline, are we seeing like a doubling? What do you sort of see in those studies,
Well, this is a question that I'm going to answer the same way. This is the type of question that I'm always going to answer the same way. Physiology doesn't necessarily give you clear numerical differences between things. It gives you directions. So, directionally, the more stress somebody's under, the bigger the problem's going to be. So it's just going to come down to, a mild stressor, it's going to create a small effect. A bigger stressor is going to create a bigger effect.
Sure, and, but potentially the effect can be quite large.
Well, if you push this right up to the top end of the spectrum where you've got traumatic injury situations and hypercortisolemia, yeah, it can be absolutely ridiculous. But, how long is a, piece of string? It's like, and everybody is going to interpret these situations slightly differently. Some people are going to interpret a situation as incredibly stressful. Somebody else is not going to interpret that same situation as very stressful. I mean, just to give a very simple example, which is not a big stressor at all, but I can show up to a webinar like we did yesterday and chat in front of a couple of hundred people, and my heart rate barely blips, but I can see just as I'm prepping for the webinar with my co-host that he's not as comfortable as I am. And that's, just kind of what you're accustomed to experiencing. So, but that everybody's going to experience stressors in different ways according to what they're accustomed to, so, and I think that's really useful to just understand is like within that group of college students, there would have been people who objectively probably were facing challenges that would have stressed other people out a lot, but were actually handling them pretty well. And the point is that many, if not the vast majority of genuine stressors are actually things that we have to perceive as stressors before they'll affect us in that way. One of the things that causes problems in animal models where you're trying to measure the effects of like for years, for example, people thought that exercise was a stressor. I mean, you still find this all over the internet. Oh yeah, that if I include exercise in my program, that's an extra stressor. No, it's not.
Yeah, well, one of the biggest beats I have with sort of the natural health world and, the space I sort of play in a lot is people will often talk about not giving a client training who has maybe any health issues or any sort of, stress issues in their life.
They don't want to add stress on top of it. And it's like, no,
adding to that stress bucket.
Not a stressor. And one of the reasons we believed that exercise was a stressor because we were using animal models without controlling for the effects of the experiment. So, for example, you'd have an experiment where they would go in and they would grab a rat out of the cage, stick it on a treadmill, poke it with a stick until it ran. And then they go, oh, look, the exercise is a stressor. And like, if you grab me from like on high and dump me on a treadmill and poke with a stick till I ran, I'd be pretty stressed as well. So now they've got models that don't do that. They have protocols of careful handling where the rats become accustomed to being handled regularly and they don't get stressed out by that, and they get accustomed to running on the treadmill so they don't get stressed out by that, and they're not then stressed out when you get to the point of doing the experiment later on. And so we've introduced protocols that get around that problem. But for many years we didn't know that, and so we were stressing these creatures out unnecessarily and then getting a stress response and going, oh look, the animals are really stressed. I'm like, yeah, no kidding. So we've got to be aware that there's effects of the experiment. If we don't understand it, they're going to create issues for us in interpreting some of these things that we're looking at.
I'm not going to mention specifically what they are because that's not the point of this, but there's two supplement studies I'm aware of that I'm kicking around in my mind where they use these particular supplements with older adults and they don't influence training or lifestyle, exercise, anything like that. And what they identify is reduction in cortisol, but they actually are associated with a significant increase in muscle mass. And yeah, based
that
on
is interesting.
Yeah, well, I mean, again, you've talked about, well, what if, because they're not accounting for diet in this study either, right? So I'm thinking, well, okay, maybe there's an effect of the cortisol on even dietary intake, and then maybe we're seeing dietary intake go up, and maybe that's having an impact there as well. But it is interesting that there could potentially be some things from a supplement standpoint that maybe could have some application, I guess, in some of the stuff we've talked about. But again, obviously fixing your sleep is going to be the main thing there to play with, as opposed to trying to, I mean, it's like that with anything we talk about. Yeah. Like people want to try to find ways to hack kind of what the body's naturally doing. And it's like, well, maybe we just don't do the thing that's causing that response in the first place, as opposed to trying to outsmart it and usually ending up second best anyway.
Absolutely. No, I mean, as I've said, that's my approach with strength training. It's approach with all of this. Physiology is it works the way it works for good reasons. If you start trying to think that you're cleverer than it, then you're going to end up getting into trouble. It's not going to, work out very well for you. So I think it's much better idea to, fix the problem rather than trying to work around it. But yeah, so.
Can I ask, so if you had an individual then who was, and maybe you touched on this yesterday in the webinar, I'm not sure, because I was in bed at 4 a.m. or whatever the time it was. But if you had an individual who was dieting and also had issues with sleep, chronically insomniac or whatever, is there, I mean, obviously we're going to see this.
They're going to be pretty
additive
miserable.
effect.
Yeah, they're going to be pretty miserable.
But is there anything worth noting in those particular cases? I mean, I guess it's all going to come back to what we've mentioned anyway from a training perspective. Is there any sort of, anything special, I guess, that's happening in that sort of combination of effects?
Well, I mean, really what it comes back to is probably taking a step back and going, do I need to put this diet on hold while I fix this sleep problem? And then when I fix the sleep problem, then go back to the project of dieting. And I mean that's broadly the answer we gave on the webinar yesterday when we had similar kind of questions. It's like, just don't try and fight two battles at the same time.
Because essentially it is two battles. Like that's basically totally what we're seeing in that combination.
It is. Don't do that. Kind of retreat, regroup, start again. Fight the battle that you that is creating the problem, and then go and fight the battle that you're interested in fighting originally. Essentially, it's two separate problems. Trying to fight them both at the same time is really, really hard. So fix the sleep one, and then go and do the diet. I would do it like that. I mean, we had a number of questions where people were saying, what if I've got this kind of, or we gave some hypotheticals around, well, people are approaching with a fixed date in mind, and it's too short a period of time to really, get it done. It's like, no, don't do that. Set a better competition date. Give yourself more time. It's the same answer. It's like, don't try and do something that's, kind of.
I mean, honestly, this sleep thing, obviously there's all kinds of reasons people have poor sleep. But in my experience, I work with stacks of clients who have poor sleep, and 90+% of the time, this is not a hard thing to fix. Obviously if they've taken care of sleep hygiene, that's going to be at least 50% of it. And then with a couple of supplementation fixes, a couple of interventions, usually people can get on top of this if they're actually interested in it. So it doesn't feel to me the kind of thing where most people need to look at it and be like, oh, I need to delay dieting by 6 months while I work out my sleep. It's like, well, hang on, this is probably a phase.
Takes as long as it takes. Yeah, I mean, it could be a 3-week problem. It could be, who knows? But yeah, I think the definitive answer is don't try and fight both battles at the same time.
But not just because it's going to make it harder. Like there's actually...
Because you won't actually succeed. You won't actually succeed because what's going to happen is you're just going to hemorrhage muscle mass. It's just going to drop off you.
Yeah. So we're not just saying it's going to make the fat loss harder. It's going to make whatever harder work.
No. It's actually not going to happen.
Yeah. Like it's actually going to cause you problems. This is not a good idea. You're not just making life harder. You're causing problems. Yeah.
You're actually going to not achieve your goal if you try and fight both battles at the same time.
Yeah. Yeah. I think that's an important message because I think people might think, you know what, I understand it's harder.
Sorry, again, none of this applies if the person is using anabolics.
Is on anabolics. Yeah, sure. Yeah. Yeah. Which is probably why this message is actually very important because as you pointed out, people might be looking at, people online at bodybuilders, whatever, and thinking, well, it's not a problem for them. I didn't need to outwill myself out of it and actually suck it up and whatever. It's like, well, no, hang on, your physiology here is actually a little bit different. Okay. There's actually a fair bit in that. Who would have thought sleep deprivation, atrophy?
Yeah, I mean, recovery. I'd never really gone into it before. So it was a great pleasure to just work through a set of studies that have been done really well and, thoughtfully, and arriving at a really nice hypothesis that's very explanatory. I'm kind of, and it happens a lot when I go into physiology and I sort of sideways from an area that I'm already very familiar with. And I find a group of people who are working on something really interesting and have done a really good job. And then I come back to hypertrophy research and I'm just like banging my head against a wall going, this is so bad in comparison. The dogma and the just willful blindness of ignoring things like fatigue and kind of sarcomerogenesis research and that kind of stuff. They're just determined not to include anything other than their own pet theories. Whereas, when you find an area of physiology research that's been well done, it's such an enjoyment. So yeah, it was fun to go through and piece all that together. So I will be doing the same thing with caloric restriction. As I presented on the webinar yesterday, we'll do it in a podcast coming up. And we'll also do some more stuff on that MPS-MPB interactions because there's more to say on that as well.
I think, again, for people who've listened to this, it would be interesting to go back to the weekly net stimulus model, play with, obviously, there's no hard and fast numbers here for atrophy, but just think about or conceptualize what does this influence if the atrophy number was a little bit higher there?
Yeah, all they have to do is bump the maintenance volume up so that the atrophy time
Well, that's exactly what I was thinking there, because ultimately you would expect this to change the maintenance volume.
Yeah, so you could bump the maintenance volume up to like, 10 sets. I don't know if the model will let you do that, actually. I mean, I'd have to ask the creator because I didn't code it. But, you could theoretically bump the maintenance volume up to 10 or something like that, and that will give you a faster atrophy rate.
Yeah, that's truly interesting thinking about it from a maintenance perspective, because we kind of just assume, 3 sets will maintain, or 3 to 4 sets is going to be maintenance in basically everyone, whatever. But actually, there could be some scenarios where that simply won't be true. Plenty to think about. Okay. Thank you guys for joining us. Hopefully that's stimulated some thoughts in you guys. And if you are struggling with sleep, I guess this is your encouragement to actually think about what are you going to do about it, and maybe not just try to outwill your way through it or have more coffee or whatever. Not that I'm against coffee, but there's definitely things you can do to support your sleep. Okay. Thank you for joining us, and we hope you'll join us again next week for another episode.